Okay, it's Mr. Ops here, and we are going to try an example here dealing with box plots and spread and comparing them. And so if I have weights of males and female students in a class, and they're summarized by these box plots, I want to estimate the standard deviation for both males and females. Well, if we remember from the past, an estimate could be I take the range and I divide it by 4. So my standard, so for A part, my standard deviation for the males, the subgroup M, well, my range, if I look here carefully, my upper value is about 235, and my lower value is about 95. So if I go 235 minus 95, that's 140. If I divide that by 4, 140 divided by 4, I end up with 35. So I'm going to estimate the standard deviation to be 35 for the males. And this standard deviation for the females, well, if I move this along, I can see this is about 85. That is about 155. So if I say 155 minus the 85, which is 70, and then I take 70 and divide it by 70 divided by 4, I get about 17.5. So right off the bat, from my estimate for, I should put little approximate values here, approximate, I can see that the males have a lot more variation than the females. The females' weights are more consistent. Now it says estimate the IQR. Well, again, I can go here. I'm going to take about 181, subtract 150. So 180 minus 150, well, that is going to be 30. So B, my IQR for the male is going to be about 31. And for the females, my IQR for the females, well, I can see here this is going to be about 128 and 116. So 128 and 116 is going to be 12. That's a difference. If I subtract 128 minus 116, I get 12. And so again, the IQR is larger for males than females. And then if I'm going to estimate the median for the females and the medians for the male, well, again, if I move this over, my males I think is about 160 versus 120. So this is 160 pounds versus the females was 120 pounds. Now, that's just doing some estimating and reading the graph. Now, for some more analysis here, for females, would you think or anticipate the mean to be as large, smaller, or about equal to the median? Median. So the mean compared to the median. Well, when I look at this distribution, it looks fairly symmetrical. And in a symmetrical distribution, the mean and the median are about the same. So I would say the mean is approximately equal to the median because it is symmetrical. So it's symmetrical. And now E part says compare the weights of both males and females. Ensure we've discussed the center and the spread. Well, I've got the numbers now. I just have to interpret them. And when I look at these, I can say from the medians, the males are typically heavier or have a larger weight than the females because the median of the males is higher than the medians of the females. So if I type this up, I can say typically the males are heavier than the females, as the median is higher. But when we look at the spread, there's a lot more variation in the male's weight. However, the male's weight is not very consistent, whereas the females are more consistent. So less variability in their weights, as shown by both the IQR and standard deviation. Okay. And the other thing that's quite important is look at this distribution here. All of the females are basically in the same as the 25% of the males, the lower 25% of the males. And that's what I would think a fairly important observation. And so what we can say, almost all the females weigh the same as the lower 25% of males. So this is the lower 25% of males, and almost all the females are in that range or lower. And so from just two quick little graphics, we can get a lot of information about the weights of males and females in this particular class. And it's more than just, oh, males weigh more than females. The idea of the spread and the variation is it makes this story far more interesting. It's more in-depth analysis of what's going on with weight.